recording. So hello everyone. Today we have the presentation by a company, and please correct me if I pronounce the name wrong. So Grycle, is that how you say it?
It is Grycle. We chose a name, a very ugly and bad name, so that everybody is gonna remember.
Well,
it.
Several students did ask what the name means, where it comes from, so that will be one of the questions I hope you will address. So the company participates in X-Culture for the first time. So I've had a few meetings and a few email exchanges about the company. So I have some information, but I'm still curious to learn more. And for the students, again, this is a new company. This is your opportunity to learn more about it. So I see we have some people watching live. If you have questions, you can always raise your hand or put your questions in the Q&A. And those of you who could not attend because you're at classes, at work, or wrong time zone, you can always watch the recording, and you can always send additional questions by email. We will relay them to the company for additional information.
Yeah, who's gonna help me with the questions? Remember, please, I'm a man.
Okay.
So yeah. a limited bunch of neurons, and essentially just one thing at a time that I can perform.
Well, it's hard to confuse you with the video and everything, but yes. So thank you. So you pronounce Daniele or Danielle?
Daniele.
Daniele.
Yeah,
okay. Yeah. All right. Well, Daniela, I think you will be doing the presentation. So we will start with a quick overview and then move on to questions from the audience and the ones sent to me by email. The microphone is yours.
Okay. So thank you. I have no evidence of the people connected. So I'm pretty sure Vasily is going to help me to have a touch of what is going on. But by the way, with your permission, I'm going to share my screen. And first, thank you very much for having me today here with you. During the past few years, we have had chances to collaborate with Stefano Elia and his classrooms, but this is the very first time I have the possibility to share something about a project that sees me directly involved together with Stefania Pezzillo, that you can see connected as well. So thank you again, and for some very strange reason, there might be many of you that it looks, they look like being interested in become entrepreneur. Please think about it twice, maybe more. This is going to be pretty much demanding. By the way, we are here open to share about that based upon our experience. This is not perfect science. Okay, so I'm sharing my screen, and please give me a sign about that. Okay.
Yeah, it's working.
So if I'm not wrong, we're going to have, let's say, 15 minutes to share something about the project, and I'd like to give as much room as possible to Q&A. So I'd like to start from the problem. That is the main point. The main point is that we are kind of inheriting the pretty much established processes of waste management that we have learned in the past centuries, and it is essentially a very strange process, very complicated process, complex and complicated at the same time. Complex because there is some objective complexity in managing waste, and complicated because we do our best to make it complex. Okay. So here you can see listed the major problems. Essentially, what we do, the process of treating waste essentially begins in our houses, in our homes, where we start by manually differentiating such. Let's keep on calling it waste. And essentially, we separate plastics from organic, from whatever. It depends locally, by nation and by region. And from that point on, a very long trip begins that sees very specialized trucks to collect our waste on a daily basis, or in several different days during the week. And those trucks are specialized based upon the nature of the material that has to be treated, and they take it away from our homes, tens and tens of kilometers away, and the final destination. So such trucks increase traffic and the emission of CO2, and there's several costs allocated because of such kind of treatment. And After several tens of kilometers, what happens is that such waste is introduced in specialized plants. Those are specialized in terms, again, of the very specific type of materials that need to be treated. So you're gonna meet, you will meet plants specialized in plastics treatment or organic treatments or paper or whatever. And so first, those plants are of huge size because internally there's a very long pattern of essentially manual separation that sees such waste being progressively separated and separated and separated again until you reach a semi-final product that can be sold or some way treated. And this process is pretty much inefficient. Just to give you an insight about that, because otherwise our discussion is going to be very qualitative. For example, in Europe, the numbers from Italy are very positive. This is one of the few fields in which we have a good positioning in the European charts for what concerns waste treatment and recovery. Okay, we are first or second for the quality of treatment. But even if
you mean your country or your company?
Italy.
Okay.
Even if we are in such good position, what happens? Just to provide you with a hands-on example. For example, for plastic treatment, more than 40%, which is a huge quantity, 40% cannot be treated. So the plastics, gets out of your home, as a very long trip to be taken to a faraway plant that is specialized to treat plastics, and as output you have that 40% of those plastics cannot be treated. That kind of plastics even has an industrial name that's called plasmics, and those you can consider those as fragments of plastics with a diameter that is minor than 10 centimeters. Okay, those cannot be treated. So what happens to that waste? That residual waste, that is an enormous quantity of waste. 40% is collected by new trucks, again, that take it tens and tens of kilometers away to the incinerator, where in the best case you have some energy or heat, or energy and heat production by while generating a lot of CO2. So
but probably also a lot of pollution. Like I don't know how. But I've seen plastic burn. It's always like dark black.
I can give you numbers. I just mentioned plastics because it's quite evident and very close to us and to our sensitivity. But the problem is more general. On a per year basis, we produce a little bit more than 200 billion tons of undifferentiated urban waste. 200 billion. It's like when you hear such numbers, you don't have a clue. You cannot have a clue of what it means. But just to provide you with some insight. Every year to treat inefficiently those 200 billion of tons of waste, we generate 1.6 billion tons of CO2. So that's, I think it's a good indicator of such an efficiency I was mentioning before. Essentially, to make a long story short, to inefficiently treat waste, we generate every year almost as much CO2 in weight than the weight of urban waste that we generate. And that's a very inefficient process, okay? And plastics is a good example, but you have whatever in that. You have glass, you have paper, you have whatever material.
Metals, probably, right? Cardboard.
Oh, definitely, absolutely. So first problem is that of managing on an industrial scale, very far away from cities, urban waste. Okay, and there's of course a lot of energy consumption. Besides the huge CO2 generation, there's a huge energy consumption, and the final result is very poor in the end, because of course we do that with a very romantic hope that we can recover the most part of the material, introducing it back to the industrial processes of transformation and to make some new products out of those materials. But essentially the purity, the level of purity, that is a very important indicator of the efficiency and effectiveness of the process, is very low. It's very low. Just to provide you with another insight and a good example, and to try to keep on hands-on sensitivity on what is going on. Every time you separate a plastic bottle in your home, you think you're doing something good as a good citizen, something very responsible. But you have to consider that in that plastic bottles, there are at least three different types of plastics, presumably. So that makes your manual separation at home very ineffective, because to have it effective, you should separate the label from the body, from the cup. Those are three different types of plastics, and with three different economic values. Okay, as you can imagine, you compact the bottle, you put it in the plastic bag, you have it 10 kilometers away from your home, and in the end, as an output of the industrial treatment plant, you have huge stacks of those plastics that cannot be purely separated. So the bottle plastic is just considered as a bottle plastic, while there are lots of industries in which the purity of the material that need to be treated is totally key. In all the industrial processes where you generate plastics for this kind of products, or the cockpit in a car, you need a very high purity, more than 95%. So having material that is not pure makes it very ineffective to be reintroduced back into the typical industrial transformation process. So please keep in mind that the purity of the material that you have as an output is definitely a major indicator of the effectiveness of the process. So
Daniele, can I ask you, so when you say purity, so when we have virgin plastic, so is that one considered 100% pure? Is that how it works? Yeah. And then when you recycle, there are different types of plastics mixed. There may be some other waste.
Yes. Generally speaking, you cannot expect to have in the final products, consumer products in high volumes, consumer products, really pure plastics. Generally, those are blends. Okay. There is a physical process to have purity that is called depolymerization. It is a difficult word to be pronounced. Depolymerization. Essentially, every plastic is a bunch of polymeric chains that are combined together through some very specific physics. To have it pure, to have a pure material, you should retransform back the final plastics into original single monomeric chains, and then you would have very pure plastics. There has been some experiments. For example, the last experiments were completed unsuccessfully in Japan around 2010 to retransform back final plastics into original monomeric chains. And such kind of experiments was abandoned because it was very, very inefficient.
Probably cost more than extracting.
Definitely in terms of power consumption, but also because there was a huge pollution due to the generation of CO2. It was totally ineffective as a process. As far as we know, there are new experiments being run at the moment, either here in Italy, but there is not any public information about the final results. So somebody's trying again. What we have invented is a kind of compromise between the theoretical pure process of retransforming back the final polymers into original single monomeric chains, and the need to have something that is pure enough to, but meanwhile economically sustainable, to be reintroduced back into industrial transformation processes. So what have we invented? The idea is essentially twofold. On one side, we realized that if we were capable of reproducing the industrial transformation process on a small scale, we might have had the possibility to bring back, such industrial transformation processes from far away to close to our homes. That is, close to where the waste is generated, because that's essential, because if we were capable of retransforming back our waste into reusable raw materials as close as possible to where such material is generated, such waste is generated, we would radically cut off all the costs and impacts related to the collection, the transportation, the transformation. Because of course, the small scale is key in that, because of course we would need a small scale machinery that is also capable contemporarily to reduce the volume of waste locally, immediately, by more than 90%. Just to provide you again with a hands-on insight, if the truck that collects plastics again from your home comes to your home once per day, but we were capable in the apartment building to reduce the volume by more than 90%, of course, such trucks should come over to pick up your plastic waste only once every 10 days instead of once every day. So I think that's a good insight of how we might cut off the cost and the impacts in terms of CO2 as well, and the cost for the municipality related to collection, transportation, and transformation. The second pillar of our innovation, of our invention, is related to the value of the materials, and that's related to the purity of the separation, the separated outcome. Because if we are capable of retransforming back as much as possible upstream, as we said before, of the chain into reusable raw materials, then such materials, pure materials, would have an economic value. You have to consider that in many countries, and Italy is one of those, already are secondary markets that process, sale, and buying of recycled raw materials. Okay, so those are the two pillars, and let me introduce you to how we do that. Okay. I have numbers on the market. We can talk about that in the Q&A session.
And we do have a lot of questions about the company itself. So I have.
You're going to be very welcome.
So you're planning to show the video?
Yep. No. First, here we have some short scheme on how it works. Here you can see a design of our former prototype. This was the fourth version of our machine. I'm going to show you a video in a couple of minutes. But on the left, you are going to see how it works. Essentially, and this is not what we essentially patented. Okay, so we kind of generate an industrial transformation process on a small scale. This is a machine that is a little bit less than 1.5 meters, and the diameter is around 25 centimeters. Okay, so as you can see, that the size is pretty close to that of an appliance, a domestic appliance. Okay, so essentially we do some shredding or grinding all together. So we have designed some machinery that is made to welcome undifferentiated waste and to grind it and shred it all in one single chamber. So what you have as an output of the first phase is kind of a blend of flakes that that are made of several different types of materials, and those flakes are introduced into the second stage, that is an electromechanical filters, and that vibrates, and it has very peculiar geometries, and the objective of such second phase is that of separating such flakes based upon geometric dimensions, subcategories of geometric dimensions. What you have in the end is the third stage, and such outcome is introduced in the more sophisticated part of the machinery, where we use spectrometers. And I don't know how many of you are confident with spectrometers, but essentially this is not new technology. That so far we used to have a look at the planets and stars far away. If you want to have a clue of what a planet is made of, you just have a look at it through a spectrometer. That is an instrument that reads the photons, the part of light, the subpart of light that is reflected by the surface of the planet. And if you check the bandwidth in which such light falls, you can have a clue of the material the surface of the planet is made of. And essentially, this is exactly what we do. We submerge such flakes, that is the outcome of phase 2, into light, very specific lights in very specific bandwidths. And then we read the reflected light through spectrometers. And because of the classification that we perform manually and automatically through the use of artificial intelligence, we are capable of recognizing the nature of the material such flakes are made of. Okay, this is how it works. But now, if I am capable of taking control, can you see I'm on a YouTube page at the moment? Can
yes, we can see it. Yes, I hope the sound will work, but if not.
Oh, no, not necessarily the sound. It's a short video that we use for our crowdfunding campaign. And there is some blah, blah, blah about the numbers, the problems, etc. But here you can see a simulation of our fault prototype. So a synthesis of what I was introducing. Everything is shredded all together. You generate flakes that go through an electromechanical filters, and you pre-separate according to geometric dimensions the flakes that enter into the light reading. And because of the automatic recognition of the nature of such materials, those are let fall into specific containers. So what you have in the end is that such flakes are collected into separate containers based upon the nature of the materials they are made of. Okay. So this is a short video. We'll have a look at it together until the end. So you're going to see the flakes that are let fall.
So this is the actual machine, right?
This was our fourth prototype. We have made during the past year a huge pivot. I'm going to show you. I'm going to introduce you.
How big is it? I'm trying to figure out, what's the size? Is it something that fits in the room? Like, what's the diameter?
In this case, as I was saying, this is a little bit, shorter than 1.5 meters, and the diameter is 55 centimeters.
So it's more like a size of a
yes,
small fridge, essentially, right?
You can consider it as a sort of a domestic appliance, but because, as I said, the original reason for that, our intention was that of bringing back upstream of the chain, the industrial treatment, as close as possible to where the waste is generated. But after that version, you can see here a picture of the new version of the machine. You can guess this is bigger. This starts to have this is our fifth prototype. This is starting to have the dimension of an industrial machinery. And that's for several reasons that we are going to have the time to discuss together. Essentially, what happened since our successful crowdfunding campaign is that there are two reasons, but one of the two, not the major one necessarily, was that several industries have started to ask us to generate an industrial version of the machinery capable of treating bigger volumes. And if you're wondering what bigger means, okay, if you want to have an industrial machine, you need to talk about a little bit, let's say around 1 ton per hour as a throughput, okay? 1 ton per hour. So this is
amazing. I mean, this is very impressive. We had a company that participated in X-Culture several times called Recycling Revolutions. It's a traditional recycling plant, apparently one of the largest on the East Coast in the United States. This is a huge facility. I mean, we are talking about, it took us like half an hour just to tour the facility. Very big, and even they said that, just like you said, a good portion of the plastic that makes it to the facility cannot be recycled. and they only specialize in plastic, so they can't really separate all the different types. So what you are doing here, I mean, this is very impressive. This is like super high tech.
Yeah, as you can imagine, if you were the owner of the manager or the manager of one of those factories, introducing our capability to generate very pure material would require to buy the closed land and to build another factory and to have many people inside. While we are insisting on generating a small machine that requires very, very little room and that might be introduced in an existing plant, because that's going to make, in our view, the difference between generating new factories and introducing such technology into existing factories. Okay.
And as you said, you know, if it has to be a large, big factory, it cannot be in the city, right? It has to be somewhere else. And if so, you burn more fuel to get the plastic to the facility. Then,
Definitely.
so if it was possible to have them efficiently and clean and compact in the city, you could save a lot of that unnecessary transportation cost and waste.
Yeah, let's talk about the concrete scenarios. While you are not going to meet any waste treatment plant in a city, inside of a city, otherwise you're going to meet other factories of, for different industrial treatment processes inside of the cities. So this is where our new version of the technology is directed to be introduced in existing plants where you have different processes to recover the waste of their transformation processes.
Mm-hmm.
And
I also imagine, Daniela, that smaller towns, like small, like little rural areas, I mean, they cannot have their own recycling plants if it's like a small population, let's say 5,000 people or 10,000 people. And as I understand, many people living, especially in the United States, you have a lot of these smaller communities.
I find it funny that you mentioned the United States, because if there's a country in the world that where I do not expect a lot of attention in waste management is the United States for regulations.
Well, regulations, you're right. The United States doesn't seem to care that much.
Yeah,
but I imagine that, right. But I imagine that in the United States, there are many smaller communities that are, like hundreds of kilometers away from the nearest big city.
Yeah, definitely, yeah.
And so they're too small to justify building a large plant. But then, so would you transport the waste literally hundreds of kilometers to the larger city, or do you just put it in the landfill, as many of them do? So if there was a way to install some sort of a more compact installation right there, I guess many of them would say, sure, let's do it. So I don't think they don't care. I don't think they do not see the need. It just becomes too difficult for them to utilize it if there is no recycling plant nearby.
Yeah,
and so your technology may be the answer.
We have considered the possibility to move the project to the United States, but we have not done it so far for essentially that reason. There is not so much commitment in managing waste. And to understand that, as you said, you have to understand that the United States is essentially like a desert country with very few people, because 330 million people around, that's more or less the population of the United States. In a huge country, there are places where you can drive for 5 hours without meeting anybody. So
for more,
we would be interested in moving the project there because of a major instead funding capacity. But we haven't done so far, and we are still focusing on the European market at the moment, because there's a lot of attention. There are rules at a European level. There's a lot of investment in projects like ours. So we are staying here at the moment.
I have a lot of questions. So can we go to Q&A, or
please, of course.
So let's go in sort of in the order. So one, the name. So Grycle, several students ask, what does the name mean? Where does it come from? Why Grycle?
I want to answer not about my project, but what might happen to your projects. When you generate a new project at a certain moment, very early, you're gonna be required to have a name. And you cannot just choose a name because you like it, because a major problem is going to be that of having a website and some social profiles and whatever, because, for example, you might need them for a crowdfunding campaign. And in that case, having a a name that can be distinguished might be a very tough job. In fact, there are even websites that support you in looking for a name, and they do some automatic research on the domain name systems to look whether your name has already been used. And such kind of research is time demanding and can be very tough. So in our effort of being creative, and you have to remember that we are men, okay, we have limits. We combine the two words, that is green and recycle, and that's the origin of the name Grycle.
Okay, so there is a logic to it. So green and recycle.
Yes,
okay.
But the major reason is that such name was not used that much for websites, and the domain names were free or almost free.
So it's like short of green cycle.
Green recycle, yeah.
Yeah.
Very low fantasy, very bad.
Yeah.
Sorry for that.
Another question that several students asked was a little bit more about the history of the company and your ownership structure. So it is a business that sort of is trying to do well by doing good. So there is definitely this very strong social responsibility component. But it is a private for-profit company, or how is it set up? Where did the idea come from? Is it a private enterprise purely, or it's some sort of an investment from the government?
This is cheating. This is cheating, because this is not a question. This is at least a dozen questions altogether.
Okay, so enlighten us. Yes.
So the whole project began in Innovits. I don't know how many of you are aware of this, and these are non-profit associations. I co-founded at MIT Business School in Milan, and we started this startup accelerator in 2010, and since then we collected more than 600 projects, and essentially 1 year in 2016. The original inventor, Eduardo Carlucci, presented this idea of working on the possibility to industrially treat waste on a domestic, let's say a domestic site.
Scale, yeah.
And we started working on that, and we built a team around him. In 2017, we funded the company, and we found the company, and we started by investing our money. And then, still around Innovits, we also created the first independent funding vector that invested some money. And we pretty quickly moved from prototype 2, or let's say 1.5, to prototype 3, and we made a lot of design, and we changed many things in the project. We introduced electronics, mechanics, and design and software. We did a lot of experiments with different types of spectrometers, and in 2020, in February, if I'm not wrong, we started our crowdfunding campaign. And very soon, the pandemic hit our campaign, and so we risked a lot not to make it. And we are pretty sure that if we had not to face the pandemic, of course, because of the pandemic, the people's minds, people's thoughts were driven by very serious questions, very serious things, and not our crowdfunding campaign. But in the end, with a very good communication campaign, we were capable of succeeding, and we collected 330 euros. And when we finished the campaign, it was, let's say, May 2020, and we realized this pandemic thing would have lasted for long. And in many ways, the pandemic helped us to kind of relent, raise our head, and to reason about our future. So before the campaign, we thought we had very clear ideas on our future, but after the campaign, we relented, and we started to create the chance for having meetings with different industries, and we realized a different concept. And contemporarily, we increased our, let's say, scouting of new technologies. And after about 10 months, we came out with a new concept that was something that we realized in the next 10 months. And this is the picture that I showed you before. So essentially it took around 20 months to totally radically change the design, the idea. And you know, in the startup ecosystem, they tend to call it a pivot. And we were very prudent on spending money, very, very prudent. We won several grants, and then we were, you know, we were more courage about spending money. And we bought a technology that we found around the world during the pandemic. As you can imagine, many startups just died during the pandemic. It was crucial to be very prudent on spending money. So when we at a certain point, we started to be a little bit more confident on our new idea, and we started to build it. And essentially it happened very quickly. Before last summer, we went to a European country to touch this new technology with our hands and to get more insight on this. And we bought it in September, and we started to build on that during the last quarter of last year. And meanwhile, many other things happened, and we won last year. We won in January. It was the first time for an Italian startup. We had MIT Business School as a sponsor, Politecnico di Milano, and we were the first Italian in history company to win the global prize from Business School as a best startup. And because of that, we were contacted by a fund in Portugal, and we got in touch through that with a Portuguese company that asked us to generate a new version of the technology, especially focused on the treatment of exhausted coffee capsules. Then we changed again our technology to make it more vertical on coffee capsules, and we started to do experiments. And this is something that happened between December and January, February. And 2 days ago, we sent our final report to the Portuguese company, and it was essentially a feasibility study that they paid to us. And in the end, we provided them with the insights about the possibility that they were already looking for in the past few years to treat and enable the separation of several different types of materials, that is aluminum, plastics, paper mixed with plastics, and coffee powder. So in the end, as you can imagine, the bigger the number of materials you have to treat, the bigger the complexity that you have to manage. And the final result has been not 100% successful, but encouraging enough. And around this vertical generation of the new version of the technology, we already have generated one new patent and 2 new concepts that we are working on at the moment. We are gonna finish the new project, just the project, I mean the design part and the prototype, by July this year, introducing new mechanics upstream of the existing machinery and downstream again. And probably you're going to generate 1, probably 2 new patents on that. And that's going to change radically the history of the whole project, because we think that's going to generate something that is not existing in the market, that is the multiple contemporary separation of several different types of materials.
Very interesting. The business model. So what is the business model? How do you plan to make money? Selling the machines, renting them out? So how will it pay for itself?
Yes. As before, I'd like to talk more generally and to use our project as just an example, not to focus on on the project. The business model is something that teachers teach you in university courses. But to make a long story short, my suggestion to all of you that want to become entrepreneur is follow money, follow the money, okay? You can work on several trials and attempts, but please never forget where money is. That's gonna be key. Of course, there are companies like Amazon took at least 15 years before having a profitable business model, okay? The business model is the most difficult part of whatever entrepreneurial project. And there are several risks related to losing sight of this objective of having a business model. For example, the major risk is, in my experience, is that you fall in love with your technology. But the risk is that you are working on a solution that is looking for a problem to be fixed. Money is very close to where there's a problem or a need to be fixed, to be fulfilled. Never lose the connection with the market, okay? In our case, as you can imagine from what we shared so far, this is a very complex startup because we introduced innovation in terms of mechanics and electronics and software. And generally speaking, when you have to do with a startup, you just find one of those three. We are 5 people and we work on all of those. So there's a lot of complexity, too much complexity. So let's try to answer your question, Vasily. We cannot do everything by ourselves. There's a lack of competence we have in the team, and there are many things we cannot do, okay? There are many things we can do, but the major lack in competence is related to transforming what we can do by ourselves, that is generating patents and prototypes. And, you know, we are not capable of transforming this into a final commercial product. There's a different product competence. Just to provide you with a concrete example, when we dimension the mechanics, we tend to over-dimension it. While when you have to generate a commercial product, you have to make a lot of simulation to size correctly, to them, to dimension properly the strengths those mechanical parts need to sustain and stand. So making a product and certifying it to be commercialized is very different from working in a laboratory to make prototypes. And we have that kind of luck or incompetence. I'm telling you that to answer your question, because it's quite clear in our case that to get to the market, we need to have industrial partners that are capable of welcoming what we can do. That is, we are working as a sort of externalized research and development for established companies. So we are proposing ourselves as a sort of externalized research and development. They collect our prototypes, intellectual property. They tend to pay us to verticalize our technology relating to their specific needs, as it happened for the exhausted coffee capsules, but also we did it for another company that I can mention that makes razor blades, okay? So as you can see, there are several vertical markets with some specific needs. We adapt our technology. We propose a vertical version of the machine, and then they decide to become our partners, funding the further development of the technology or buying the possibility to commercialize, you know, the technology in very specific markets based upon geography, time, and markets. So
it sounds like there are quite a few options, from selling the license to the technology to working with someone on manufacturing. But ultimately, the idea is that somebody will be making the machine, either you or your partner or somebody who buys the license, and then the money will be in selling the machine, right?
Selling the machine in the end, and we have money in 2 different ways. First one is royalties. As soon as we provide our industrial partners with a license, with some exclusivity to commercialize the final product, we get some money per every single machine that is sold. And you have to consider that the final machine, the price goes between 150,000 to 270 or even 300,000 euros. So they are very expensive machines. Second way is by being paid because of working as research and development to verticalize our technology and generate a new version for their specific needs.
How about selling the recycled materials? I assume you can get the waste essentially for free. Probably some cities will even pay you to take the waste. Can you treat it and then sell? I mean, you know, recycled plastic, metals, paper, they do cost a lot of money. And
Yes.
so is it possible to then simply sell the
It
material
is
and make money that way?
totally reasonable what you're saying. And I have to admit that inside of the main bulk of partners, there is someone that since long is thinking like that. You have to consider that we are set up, as I said, 5 people plus somebody else collaborating, less than 10 people. That kind of
so yes, can I highlight here? So for the students, as you're watching, remember that the question is for this particular startup at this particular stage with 5 people, right? So it's not so much the future of the recycling industry. So that's an important and big question. But for now, we have a company that many of you will have. You have the idea, you have the technology, but you're still a very small startup with 5 people trying to sort of make it work. And so the question is, how do we go from here to here, not how we go from here to, you know, to saving the world. So that will come later on.
So to answer you, if we were a bigger company, we would be working exactly on what you said. So we expect to get to a certain point and size to exactly the scenario you were proposing, that instead of making money out of the material we generate. At the moment, we need some help to do that. We have not the strength by ourselves to do that. As I said, 5 people working on mechanics and electronics and computer science is a lot of work. That's enough.
Yeah, so there is a question from a student. I didn't see it. I'll read it. It's a long question. So coming from Southeast Asian country with waste as one of our biggest problems, often causing floods in cities, the product comes up as very intriguing to me. As you have mentioned, Grycle has been working and prototyping regarding the industrial size product. How do you approach this product? Will it be commercially available and when? Do you think it will be available by 2020? My country produces 67.8 million tons of waste in 2020, or maybe even billion, so it doesn't say here. So basically small ones, but are you also working on the larger machines? And if so, how soon do you think they will be available?
We are working definitely on the large machine for several reasons. One major reason is that there are countries that do not allow you, in terms of regulations, to manage on a small scale your waste. There are countries where your waste is not your waste. The waste you generate is not your property. So as I was introducing before, there are several reasons why we are moving to a bigger scale machine. And one of those is that several industries are requiring that for their specific needs. So definitely we are moving to a machine that is supposed to work 700 kilos per hour and ideally 1 ton per hour. That is a proper industrial size. And our hope is that, let's say in 1 year, if we convince, for example, the Portuguese company to invest in our project, we might get to a final version of the whole transformation phase. Just to provide you with some insight about that, what that means. I have another video that I can show you. So am I sharing my screen? I don't remember.
Not at this time, no.
Okay.
And Stefano, I see you raised your hand. You had a comment, a question, or so the video's here.
Let's wait for the video.
Yeah, give me a second here. I'm switching off the audio because it's very noisy and very annoying.
This looks
have
like
a look at
chocolate
this.
making.
No, yeah, not exactly. That's already being shredded coffee capsules. Here you can see the coffee powder that is automatically separated from plastics and aluminum. I'm showing you this just to provide you with an insight of what moving to a bigger scale means. Essentially, we started from one single machine having all the 3 phases embedded and directly connected one to the other. While when we move to a bigger scale, we are actually separating the 3 phases and introducing 3 different machines. So we are used to calling it a machine, but essentially is now an entire transformation line where the three phases are subsequently executed, you know. So you have the shredding machine, you have the sieve, the electromechanical sieve, and then you have the reader with the spectroscopes, and essentially we might have another fourth phase, and it's going to be the separator. So even if we call it a machine, it's going to be a line, a transformation line. Still, you know, we keep on insisting to make it as small as possible, and that's going to be our final result. So we hope, let's say, by the end of next year, to be capable of commercialize the machine.
Yeah, fair enough. Stefano, you had a comment or question?
I'm like maybe to ask Daniele if you have maybe a broad idea of what type of countries you prefer to target, like geographic areas, or you are open to any type of market. So you prefer to start from, I don't know, European closed markets, or some specific type of market based on characteristics that they are more suitable for your type of products and so on and so forth, just to give some guidelines for the people who are going to take up your challenge. And then
yeah, there is a lot of reasoning behind this question. Let's try to make some order. First, there's the funding viewpoint. From a purely funding viewpoint, you have to expect that the funds expect to invest in companies and projects that were born to be global. Otherwise, it's a small and medium enterprise. So if you look for that kind of funding, and it depends on your project. In our case, it's quite evident that there's a lot of capital consumptions, you know, as I said, mechanics and electronics and software, a lot of work behind that. Second point, the geography. It depends on the commitments of that geography related to your country. If that's a country where you have very strict local rules about waste treatment, probably that's not a very friendly market. And it might look strange to you, but Italy is one of those markets. Very difficult in Italy to generate a small machine to be introduced, for example, in an apartment building, because in our country, local treatment of waste is simply illegal. Europe, by the way, is a very favorable region in the world, because at European level, there's a lot of attention in terms of European regulation for what concerns, you know, for the future upcoming investments in projects like this one. And this is not a case. We are currently running for an EIC. I don't know how many of you have already worked on projects that were used to be named, being named Horizon 2020. Okay, the legacy of Horizon 2020 is EIC, Eco India Corner. Okay, that's new grants that specifically are in favor of projects related to recycling and green technology. Just to provide you with a concrete insight, 30% of the whole fund is dedicated to these kind of projects. Plus, you can concur to the remaining 70%. So there's a political, very clear positioning in Europe about this kind of projects. Instead, if you go to the United States, as we were saying before, in the United States, people, they just don't care about waste. They just hide their waste in landfills, and there are many places in the United States where they take waste and they just don't care.
Is that true, Vas?
I think it depends. So generally, it seems to be the case compared to Europe. But in the United States, most of these questions are very localized. Yeah. So you have some states like California takes recycling very seriously. You have some cities. So it's always at the level of the smallest sort of municipality where those questions are made. So therefore, yes, overall, I think that's true. At the same time, there may be quite a few smaller cities or bigger cities that do take it seriously. So it's a very diverse country. So from that perspective, I think there may be pockets where recycling is taken seriously.
Meanwhile, there are countries like South Korea where there's a lot of
that's the whole country, or Japan.
I would not be Japan. I would not be surprised to discover that the lady that posed the the last question was from South Korea. There's a lot of interest in those countries related to this kind of project. Of course, if you ask a startupper where they would, like to move the project to, they always say globally everywhere. But please remember that we are 5 people and we are already doing miracles. And you every day have to face the limits and that working in a small company are. And when the difference between, there are many differences between working in established companies and in a startup. One is that every time you make a wrong decision, you might die in the next 3 months, maybe even before. Does it mean that you cannot take decision? No. What it means is that you have to take decision very prudently and in a sustainable way. So, for example, you need to work with very strict and short cycles. So you have to make many little experiments and to see the results in a short time. You cannot expect, as it happens in established companies, that you have the marketing guys that, scheduling a meeting where they say, okay, I know the future, guys, let's invest 10 million for the next 5 years. We enter this new market. This is not a startup. A startup, you have very little money. You have to pay a lot of attention to your investments and to hope to have understood the market and to hope that meanwhile, while you're working to make your prototypes and your products, the market has not changed.
Very true, very true. Well, we are pretty much out of time. We have another webinar in 1 minute.
Which is a pity, we were having fun.
So this has been very informative for the students, again, for watching the recording. If you have any questions that have not been answered here, do send the questions to us. We will relay them to the company and then back to you. And then we will see if there are many questions. Maybe we'll do another webinar.
Let's get in touch. Let's get in touch. Okay.
Yeah. Thank you so much. And those of you who have time for the next one, we have the meeting with Differ Chat next. So you're invited. It's a different link, so you'll need to log out and then log in. We'll see you there. Thank you so much, Daniele. And thank you so much, Stefano.
Thank you, Vaz. Thank you,
Daniele. Good luck with your
Daniele.
startup. So let's hope the students bring a lot of good ideas to you.
Thank you very much. Have a nice day, all of you. Bye-bye.
Bye.